let's start with answering an interval notation. We've got a inequality with a quadratic. I can show you it's a quadratic. I'm just going to move everything over and have it zeroed on the other side. So add 5x and subtract 14 to both sides. I get x squared plus 5x minus 14 is greater than or equal to 0. I know before I do anything else, if I were to draw a number line, I'm going to have two numbers that are going to have, they're going to be included. And I know that my arrows are going to be pointing away from each other. Before I do anything else, I know that. I just need to find out what those two numbers are. Okay? How do I know that? Because it's greater than. The inequality has that the polynomial is greater than 0. So that means these answers are going to be included because it's equal to, but away from each other because it's greater than. All right, let's find out what those two numbers are. X and X, 7 and 2, I think. Yep. And then set these each equal to 0. X is equal to negative 7, and X is equal to 2. So there are my two numbers. Now, it says answer in interval notation. All right. Well, left to right, I'm coming from negative infinity. Stopping at negative 7, it is included. Or including 2 and heading off to positive infinity, which those get parentheses. So those are my answers. The next one, I was going to show it to you on Desmos, but I don't need to. We need to know what is going to make this fraction 0. So I'm going to take 1 minus 2x, and it has to be, well, basically what I'm doing is I'm finding my domain. That's what I'm doing at this point. That's what all of this is. So to find my domain for this inequality, I need to take my denominator and make sure if I want the numbers to be in my domain, it needs to be greater than 0. Because if it's less than 0, then it's a negative. Hold on a minute. No, it has to be greater than. So it has to be greater than 0. Because if it is 0, it's undefined. All right, so I'm going to subtract 1 from both sides. Greater than negative 1. And then when I divide by my negative 2, that flips my inequality and makes it x has to be less than 1/2. So all I have to do here is show, I'll draw your number line so you can see it. It can't be included because that makes the denominator 0. And x has to be less than. So it's coming from left to right, negative infinity, stopping at 1/2, and it is not included. I know that it has the equal to here, but if you have that 1/2 equal to, then that's what goes into x, and it will make this denominator 0. So this is our domain. Okay. Find the real zeros of the following function and state the real zeros for each and whether they touch or cross. We're looking for the multiplicities. All right. So we've got x, set that equal to 0, x minus 2, set that equal to 0, and x plus 1, set that equal to 0. We're going to find our zeros first, which are our x values. 1 is 0. Add 2 to both sides. The other one is 2. And the third one, subtract 1 from both sides. X is equal to negative 1. Okay. The multiplicities of each. 0 has an exponent of 1. The 2 has an exponent of 2. And the negative 1 has an exponent of 3. Now, do they touch or cross? 1s and 3s, the odds cross. The evens touch or bounce. I'm writing counts. Of course I am. CH. There we go. All right, express the product. Be careful. I could have you adding these two binomials. I could have you subtracting them. multiplying them, dividing them. Let's do all just to CYA, just to make sure you know how to do all of these. So if I give you 5 minus 7i plus 4 plus 2i, I'm just adding them. The parentheses go away. 5 plus 4 is 9. Negative 7 plus 2 is negative 5i in a plus bi format. Let's subtract them. 5 minus 7i minus 4 plus 2i. The parenthesis goes away over here, and this one can't go away till you distribute that negative. Negative 4 minus 2i. Okay? 5 minus 4 is 1. Negative 7 minus 2 is negative 9i. And there's the a plus bi format. Let's do what we have here, which is multiplying them. So for 20, I'm just distributing. Outer inner, negative 28 and negative 14i squared. Remember the I squared is equal to negative 1. So this becomes 20 minus 10 minus 8, 28. Oh. And then plus 14. 20 plus 14 is 34 minus 18i. There's the a plus bi format. That was the actual answer to this question. And I want to do one more. I want to do the division. That should be minus over 5 minus 7i over 4 plus 2i. Remember, you have to have the complex conjugate in order to rationalize that denominator because it is currently not rationalized. So you have to multiply by, well, if 4 plus 2i is the term in the denominator, its complex conjugate is 4 minus 2i. Okay? So 4 minus 2i over 4 minus 2i. And you just have to multiply both the numerator and the denominator. So 20 minus 10i minus 28i plus 14i squared over 16 minus 4i squared. The I squares become negative 1. Alright, so that becomes negative 14 plus 20 is 6. Negative 10 minus 28 is negative 38i over 16. Negative 4 times negative 1 is 4. 16 plus 4 is 20. This is not the way to write it though. A plus bi format, it's going to be 6 over 20 minus 38 over 20 and the I. You need to reduce though. 2 goes into both of these, so 3/5. And 2 goes into both of these, so that's going to be minus 19 over 5. What am I doing? 5. 2 into 20 is 10. Crack smoker. Okay, not sharing. So negative 19 over 10i. That is the actual answer. All right. I think we need to take a break. I'll see you in the next video.